Good morning, Tahmina Khan is here in TKMaths is fun. In today's video, we will solve a question on work power energy, which is a part of the syllabus of A-level mathematics M1. So this question will not only solve, but also help you to understand the concept of the topic. So the question I've taken is from June 22, variant 4.1. So question is in front of you. So let me highlight the important points of the question. Talking about two racing cars. They are at the starting point O on a horizontal straight road, right? And the mass of car A is 1200 kg. And the engine of the car A is producing a constant driving force of 4500 newtons. And there is a point P. When A arrives here, its speed is 25 meter per second. I have rather sketch here this for you to understand it better, and all the information which I am reading I have jotted down here. The same I would ask you to do it so that there is no confusion is writing down the values later on if you are referring the question. So it's better put down all the values here. So the distance OP is d meter. The work done against the resistance force experienced by A between O and P is 75,000 joules. You have to show that distance from O to P is d. So let's focus on part 1 first of all, and we will use here work energy equation, right? And you know, in my previous videos also I've discussed that work energy equation in the very simplest form is mechanical energy initially at the start, and then at the end will be same. In between there is work done, right? That work done is maybe energy is increasing in the system due to some force, or maybe to overcome some frictional force energy is taken out of the system, right? So this is mechanical energy plus minus work done is equals to mechanical energy at the end. This is the energy equation for you. Now mechanical energy we know is potential energy and kinetic energy. Because we are talking about the race on the straight line, there is no question of potential energy in it. So we will not discuss potential energy, we will only talk about with respect to kinetic energy. So now the work done by engine will be plus because it is giving energy, and work done to overcome the resistance or the friction, that is the energy taken out from the mechanical energy. So now this is my equation, and now I will substitute the values here. Kinetic energy is half mv square, you can see here. And work done by engine, we know work done is what? Force into distance. Distance is d and force is given to you in the question, which was what? I have written here, I'll show you. And work done against resistance is given to you also 75,000, right? So the force of the engine was given to you 4500. Initially the car was at rest at O, so I have written 0 because velocity was 0. But at point P the velocity was 25 meter per second. So I have plugged in the value and I will solve the equation to get the answer of D, which is 100 meter, and we have proved it, right? Now let's see part B. For part B, it is with reference to car B. I have again put down all the information of car B here from the question. So let's read it here. The car B is also starting from the same point O. That's why I've written here B, okay, at point O. And engine of B is producing driving force of 3200 Newton. So I've mentioned here. And car is experiencing again a constant resistance of motion, 1200 Newton. So exactly in the same way we have done in part for car A, we will do for car B, okay? Everything same. Kinetic energy plus work done by engine and minus work done against resistive force. So in this case, both the cases it is given here force to you for the resistance and for the driving force. Whereas in part A, it was given here work done against resistance. So directly. But here we will calculate it. Force into distance. And now distance we know. Yes or no? Okay. So now you have to find out the mass of car B, which is here, the main question. So distance we already know now. We have the equation, we will algebraically solve it and get the answer very quickly. Now this part C is actually a little challenge for students. Part A and B was okay. Find the steady speed. Now you know when cars are going from O to P, they were accelerating, right? They had the same speed, but of course it was a racing track, so they were going faster. Now what is saying here, find the steady speed which B can maintain. Now they are talking about certain speed for B which it can maintain if engine is working at the same rate when it reaches at P. Now we don't know what was the engine power at that point when it reaches P, so we will calculate that first, right? So first of all, let's calculate what was the engine power when the car B reaches at P. We know power is equals to force into velocity. And force was given to you, 3200 in the question. Here it is. Here, you can see. It was given to you here. The driving force of the car B is 3200. And the velocity is also given to us when it reaches at P was 25. So this was the power of the car B at P. Now because we have to find out the speed which it can maintain if it will use the same power afterwards. So we know F is equals to ma, Newton's second law of motion. And we also know power is equals to force into velocity. If I manipulate, force is equals to power divided by velocity. So now, because I'm talking about the car in terms of force, so I will use this equation. This will be my forward force. And my backward force will be which one? Resistance. So I will form this equation. And I'm writing equals to 0 because acceleration is 0. And why it is? Because of steady speed he's talking about now onward. So I can write here 0. Okay. So now resistive force was given in the question 1200 and forward force by engine is P over V. I have to calculate this velocity. Power I have just calculated, it is 80,000 and velocity I can calculate now. So I got the velocity 66.7 meter per second. So I hope you understood it. Thank you very much for watching it. Please press like and subscribe button to encourage me and share it with your friends. Take care. Allah Hafiz.